So given two parallel lines and a transversal, what must be true about corresponding angles? So what must be true about, say, this angle and this angle? Well, by the corresponding angles postulate, if a transversal intersects two parallel lines, then the corresponding angles are congruent. So I would say the angles must be congruent. In the diagram below, line M, here's line M, is parallel to line N, which I would have also known that by the two triangles, with the transversal line C. So which other angle would be the alternate interior angle to BEF? Well, there's BEF, this one. So alternate interior would be this one. So that would be angle ABE. So that'd be this one, C, ABE. Now we're going to prove the vertical angles theorem. And normally we're supposed to prove that 1 and 3 are congruent. And the vertical angles theorem says that 1 equals 3 because they're vertical angles. But we're going to actually prove it by going 1 to 2 and then 2 to 3. So the first thing, what I'm given, is that 1 and 3 are vertical angles. That's a given. And then I know that 1 and 2 are supplementary. I also know that 2 and 3 are supplementary. So angles that form a linear pair are supplementary. To be supplementary, that means that when you go 1 plus 2, you get 180. 2 plus 3 is 180. So the sum of the measures of supplementary angles is 180. Well, if 1 plus 2 is 180, and 2 plus 3 is 180, if they're both equal to 180, then they're also equal to each other. And that's called the transitive property. Now from here, I have 2 on both sides, so I subtract it away, and that's called the subtraction property. So if I go minus 2 here, minus 2 here, then I just get 1 equals 3. And now I just proved that 1 is congruent to 3 because angles with the same measure are congruent. And so I just proved the vertical angles. Prove that the measure of angle 1, so where's 1, is congruent to 16. So you can't just say that this and this are alternate exterior. You have to do something called angle hopping. So you're going to go from here to here to here to here. And so first thing I'm going to do is I am going to go from 1 to 5. And I'm going to say the measure of angle 1 is equal to the measure of angle 5. How do I know that? Well, 1 and 5 are corresponding angles. And it's also worth noting that this symbol means that this is parallel to this, is parallel to this. And then the other way, this is parallel to this because they have two triangles. So I want 1 to 5. Now, I'm going to go 5 to 10, or we'll go 5 to 9. And I could use the same excuse. I could say that measure of angle 5 is equal to measure of angle 9. Why? Because they're corresponding angles. from there, I could do one of two things. I could go 9 to 13 and say that those are corresponding, and then say those are vertical. Or I could do a big jump and go 9 to 16, because 9 and 16 are alternate exterior angles. Just to be consistent, and it's probably easier, I'm just going to go 9 to 13. So I say 9 and 13. Measure of angle 9 equals measure of angle 13 by the corresponding angles postulate. And then finally, I'll go 13 to 16. 13 equals 16 because they're vertical angles. So 13 equals 16. And I call that the vertical angles theorem. Now I'm not done yet. If 1 equals 5, and 5 equals 9, and 9 equals 13, and 13 equals 16, then that means 1 equals 16 by the transitive property. So step number 5, which is what they asked, if 1 is 5, but 5 is 9, but 9 is 13, but 13 is 16, that means that 1 is 16. And a property that says you could do that is called the transitive property. Looking above, I have 1 is equal to 16, which that's what they wanted me to show. Alright, next we have algebra mixed with geometry. So I have 12x, I have 10x plus 20. We know that these are called alternate exterior. And if you look at the alternate exterior angles theorem, it says, and you have to assume that these lines are parallel, otherwise you don't know. So let's assume that they meant to tell us that they were parallel. But the alternate exterior says if these are parallel, and that's a transversal, then those are equal. They're congruent. So I know 12x is equal to 10x plus 20 minus 10x from both sides. I get 2x is 20, so x is 10. So they said find x. I'd say x equals 10. Next, we have this one and this one. The relationship between them, those are corresponding. We know corresponding angles are congruent by the corresponding angles postulate. So I could say 5x plus 25 is 135 minus 25 from both sides. I get 5x is 110 divided by 5, and I get 22. So x equals 22. Okay, let's find the relationship between this angle and this angle. Those are called vertical. By the vertical angle theorem, we know that those have equal measures. So I could say 19 equals 3x minus 2. If you want, you could put the whole thing backwards. if you like the x on the other side. Add 2 to both sides. 3x is 21, so x is 7. Okay, let's find the relationship between these two angles. Those are what we call alternate anterior. An alternate anterior says if we know that this is parallel to this, and that's a transversal, then those are congruent. So I know 3x plus 10 is 85. So I minus 10 from both sides. Divide by 3, and I get x is 25. These two angles they're next door to each other. They're also together on the line. So because they're on a line, we call those linear pairs. You could also call them supplementary. But we know that this plus this is 180. So I know 4x minus 8 plus 52 equals 180, because these are what we call linear pairs. We know linear pairs are supplementary. Negative 8 plus 52 is 44. Take away 44 from both sides, you get 136. Take 136 divided by 4, and you get 34. Next, we know that this angle plus this angle, we call those complementary. They add up to 90 degrees. These are complementary. So I'd say 2x plus 5 plus 3x plus 15 is equal to 90. 2x plus 3x is 5x. 5 plus 15 is 20. Subtract 20 from both sides. Take 70 divided by 5, and you get 14. So x is 14.